In this video, we go through all the geometry formulae that you need to know for National 5 maths. So the first one is the area of the triangle. So if you have a generic triangle and you have the height of the triangle and the base of the triangle, then the area of the triangle is a half b times h. Next up is the area of the square and a rectangle. So let's say the side length of the square is A, and the side lengths of the rectangle are L and H. So the area of the rectangle would be L times H, and the area of the square is A squared. Next up, we have the volume of a cube and a cuboid. So let's say the side lengths are L, B, H for the cuboid, and the side length is A for the cube. So the volume of the cube is A cubed, and the volume of the cuboid is L times B times H. Okay, next up we have prisms and cylinders. So if the cross section of the prism is A, and the length of the prism is L, then the volume of the prism is A times L. And then if you have a cylinder, so a cylinder is simply a circular cross-section prism, essentially, then the volume of the cylinder, so let's say the cross-section is A once again, and then the height is H, then the volume of the cylinder is A times H. And you can see that this is basically the same formula as the prism one. It's just that the cylinder is tilted the other way. And then we have pyramids and cones. So these ones are in the formula sheet, and I'll just indicate that by putting a tick next to the formulae. So if you have the height of the pyramid, and then you have the base, the area of the base as well, and then you have a cone as well, so I'll just draw a cone. So the height is H. Then the volume for both shapes is simply a third A times H. And you get these in the formula sheet. So I think the one for the cone is given as 1 over 3 pi r squared H, because pi r squared is the area of the circular base. Okay, next up is the volume of the sphere, so that's just sphere. And then you have the radius of the sphere, so let's say that's r. Then the volume is V equals 4 over 3 pi r cubed. Okay, let's move to the circle formulae. So if you have a circle, and then you have the radius and the diameter of the circle. So the radius is r, diameter is d. And of course, the radius is simply half the diameter, so d is 2r. Then the area of the circle is pi r squared, and the circumference of the circle, so that's just all the way around the perimeter of the shape. That would be pi d, which is 2 pi r. And the reason these are equivalent is because of this relationship. And then you have the sector formulae. So if you have a sector of a circle, and then you've got the central angle and also the radius of the sector, then you can use those to find the arc length and the area of the sector. So the arc length, so that's just this length over here. That would be theta over 360 times the circumference of the circle. And then the area of the sector is theta over 360 times the area of the circle. And if you wanted to go the other way, so if you were given the arc length or the area of the sector this time, and then you wanted to find the central angle using that information, you can do that using these formulae. So to find the angle using the area of the sector, it would just be area of sector over area of circle times 360. And to do that using the arc length, it would just be arc length over circumference times 360. So this gives you the angle at the center. Okay, next up are two important formulae to do with lengths. So I think all of you know this one already. It's the famous Pythagorean theorem. And it tells you that a squared equals b squared plus c squared in a right-angled triangle. And to find the other, sorry, that should say c squared equals a squared plus b squared. If you wanted to find one of these sides instead of the hypotenuse, you can do that using the rearranged versions of this. So a squared would be this expression, and b squared would be c squared minus a squared. And there's actually a 3D version of the Pythagorean theorem that you can use to find space diagonals. Now, what a space diagonal is simply a diagonal in a 3D shape. So this would be a space diagonal, for example. And if that's D, for example, and then let's say these sides are A, B, C, then D squared equals A squared plus B squared plus C squared. So that allows you to calculate a space diagonal in a 3D shape, like a cuboid, for example. And there you have it. Those are all the geometry formulae that you need to know for National 5 maths.